So I guess I should start. So just some admin thing first. Homework 2 will be uploaded, available to you later this afternoon because I'm doing final checking. Again, like the last time, we give you a very long deadline. It's after the more like 10 days, more than 10 days. So it will be a little bit longer than the compared to first assignment, slightly a little bit longer than the let me share the screen because I guess the slightly longer than the first one, but you will see the questions are pretty straightforward. Will be similar to say the first one, calculate the fair contours twice, 3 times, twice, and then do some probability theory, do some base rule, and then do some counting, just 3 main questions, and then some sub questions. So there's no programming for this particular part, but just basically calculation. So those who know then should not be an issue. Okay. Now, today we will be going over the R again because something we haven't covered. Okay, last time we have like the mic is here. Is it okay? So the thing we have covered is creating the our own function of our own calculation of variance, right? And this is the programming that if we change this number, right, and then all the calculation can run for once, right? The question is, this thing is like we always repeat the same line of code, right? So the question is, can we have more efficient way to do it, right? Just like we can write a custom function, okay? That would be basically the main goal of today is to teach you how to write function. And probably you know what function is. This is what the random variable, right? You give me input, I give you output. So basically it's maybe this mic is not working very well, but let's go there. So the question is like is it this one okay? Is it okay? So the goal is like this guy first. The goal is like we really want to simplify our code. We don't want to see this over and over again, right? Can we simplify? Because if you calculate many variants, then we need to copy ourselves many times. So one of the goals of writing programming is to be smart, right? So avoid repeating yourself. So how to do it is we will do it what we call in terms of a function, okay? And how do we define a function? Okay, function is like you keep repeating. Okay, so this is an example. The function is here as a function. An R name is called as a function. Okay, same as the what we see in the math, the function. So it just what you do is you give me the x. Okay, and x here can be anything. Okay, x can be a number or can be a vector. Okay. And you plus 2, and this calculate to the y, and return y means you give me back the y. Okay. And this is a function that what it means is if you give me whatever input, I'll add 2 to it. Okay. So you say my function 4, you can imagine the answer would be 6. Okay. Because this is what it's doing. You put 4 here, 4 put inside here, 4 plus 2, 6. And give you back the 6. Okay, so let's go to the R, and so let's try to calculate range. Okay, by using the what you learned before. So let's open the R Studio, again, maybe just 2 weeks from now. What you do is this console and this environment and file. Go to file, new file, and our script. Okay. Maybe I make the font size a little bit bigger before I go forward because it seems to be a little bit too small. Let's apply. It's slightly bigger. So here is the interface. Okay. So just to what you do is I have to create a function called range. Okay. So I will be called, okay, maybe call my range. Okay. And then I have this less than or and then a dash. Okay. It's a call function. Okay. And this function here, I only have one input is x. If you have more, then you have comma and y, then you have two input. But here x can be a vector, so we can put data there. Okay, x will be a vector. Okay, and then you have to have a curly bracket. Okay, and if you enter one curly bracket, then the other one will be appear for you automatically. Okay, so once you put enter, you have this. Okay, so you want to do some calculation on x. Okay, once you do it, maybe y is equal to something. That question mark I left you to do, or you at the end will be return for y. Okay. I leave you to do it. Okay. So the question is what is going to input there. Okay. I give you 3 minutes to do it. You may check out your notes and figure out what to do it. The range. Remember, range is the biggest number minus the smallest number. Biggest and small how different they are. Okay. Try to do it. Get the notes and figure out what. Yu, I mean, I think you can hear. Can you hear? Can you see? Oh, sorry, can't see my R. Oh, sorry. Can you see that? So, and what we want is I create the range. Okay. So basically, what we want to do is the create a function that calculate range. So I have my range and then assigned it by a function. The input is x, the output is y. Okay, and then what I handle the x. Okay, do note that x here in the R is can be a scalar or vector, but here we want a vector, of course. Is that okay, Anyu? Yep. I hope that's okay. After this class, then probably you can have a safely write confidently in your CV that you know some basic R, because after this, then basically you know the how to construct a function, and if later you learn how to do a if conditional loop, then basically you know most of the calculation that you need to go forward on your own. But I give you 2 more minutes. I'll let you do it. I go around. If you have any question, just raise your hand and I will answer it. Once we test your function, you can do that. Say x is
equal to C of 1, 2, 3, 4, 5. Okay. And you should say my range of X. Okay. And maybe you have a Y is equal to 1, 2, 3, 4, 50. Then you can also try my. Okay. So do note that between the function like X and Y, is it divided between the function? So both sides can still be. So no need to question from you guys. Then let me write down the answer. Range, remember, is the max minus mean, right? It's maximum minus minimum. So we know max is really give you the maximum, and actually what minimum of y x give you minimum. Okay, then we're done. Okay. So look, you can see if I highlight this one, and I run it, and you can see here immediately you have this my range in the memory. Okay. And actually, when you click this guy, then you will show you the what the function is. Okay. So you can, or other way around, if you type here my range. Okay. You type in the console. You type it without putting the bracket. Interesting part is you can see here the I'll show you what the function it is behind. Okay. So this is one of the strongest point of R is every function except the very baseline function, you can see what the code is written behind. Okay. The good thing is you know how people write their code. Okay. One thing you can learn from them. And second is maximum transparency. Okay. You know what's going on there. Okay. There's no hidden black box there. You can always check what's going on. So that is a good thing about R. Those thing is not shown in R is usually the some of the code written in C plus C. That is an underlying code, which is you don't really need to worry. Okay. So now let's check this function. It works as intended. So this example, and then when you write the function, you usually have to check whether you are doing right. Okay. So here I highlight the fifth line and the sixth line, and I run it. This run as I expect because data from 1 to 5 and the range is 4. If I highlight the 7th, 8th line, then what I have is 49. Okay. So before I proceed, is there any question? Is there any question? Now just go around to make sure that. Okay. Any question? If no, then we go to the next one. Angyu, is it okay? Okay, good. So now I hope you can see the slide. If not, let me know. So we have done this exercise, right? Calculate the range. So the next thing is how we can incorporate this because R only have the population, sample variance. So this is how you make the function of population variance, right? Remember the middle one is what we covered last time, but just let me go over again in case you forget, right? So this is a function is the x, right? And calculate the n is length of it. Calculate the mean, just x bar, and you subtract from the x bar, get the deviation, and you have the square deviation, and then adding all the square deviation and divide by n actually give you the population variance. Okay. So here's example that how to calculate the standard deviation population, right? So input x, you minus the mean and take square and calculate mean of square deviation, right? Just because sum of them divided by n, okay? And you return the square of root of that, okay? Then you give you this formula there, okay? The standard deviation P. Now, last time we didn't cover the shape, okay? So for the shape, you need to have a download package called moments. And unfortunately, this moment basically calculate population, okay? So we'll be writing a function to calculate the sample one, okay? But before we do it, let's go again and see how to download the package, okay? How to download it. Go to the right bottom corner, there's a package. Click the package, okay? And there's a button called install. Go to install. And we'll be doing moments. Okay? Moments. Okay, then just click install. We will do the install moments. Okay. Now we'll quickly install. So now what the next do is we do skewness and kurtosis. Okay. You do moments. As I mentioned in the last class, you may do the moment, and because we are using a package moment, so we have to do the library first, right? So you have to go to the, usually go to the very top, to the library, moment, or if you don't like, you can just go down here, the moment here, just click it, okay? Just click this guy, then should be fine, okay? Or you can have here, write down the comment, okay? The command, and we have skewness, okay? And we want the data, say X is there, which is very convenient, we do moment, okay? So this is expected because symmetry, so X should be 0. And you can do the same for Y. Okay, so this gives you what you expected to have, okay? Skewness and kurtosis. And again, we have a kurtosis, okay? X and kurtosis Y. I hope it is not so difficult for you to do, to take this out. Okay. So now, instead of relying, let's do the example by ourselves. Instead of relying on the moments package, we write our own skewness and kurtosis. So what I want is we have to write two functions. It's called my skew, say. This is function. Again, I have X, okay? And I say Y is equal to something, and I return Y. Okay. And I calculate the population version. So you go back to the slides. The population version is this function. Go back to your so this is the function, okay? So this is the formula, okay? So what I want you to do is to write your own formula for skewness, okay? We need to calculate. I give you X, you give me a skewness, okay? So this exercise, do it now, okay? Check the formula. I show you the formula here. Give the slide. You don't need to go back to your own. Look at this formula. Don't know how to do it. Look at how I do the population variance. Figure out how to. By a function that calculates the population skew. Answer by comparing what the official. Those who know that, I'm sorry, but just repeat it a bit before. So what we have been doing here is to write a function. So what's function is, look at this. Very simple one is a range function. A function is you have the name. Here is my range is function name. A function, you have the same function. The word function is exactly the same as a math function. Give me the input, I give the output. That's why you always again have return, and return y is return what is y. Okay? So y is something to calculate, and y is calculated. Range is max minus. So what we want you to do now is to write a function that calculates population student. And with the time, you can do the process. The population kurtosis because you can check. Okay. So, of course, you don't have to write the y, you can write z, whatever. Okay. So maybe to give you some hints, let's do the numerator first. Okay. Can we do the numerator and give you some idea how the numerator is being done? Okay. So the numerator will be, we need to calculate. So there are 3 ways. Okay, there were most numerator thing to do is do it step by step. Okay. Calculate this. Calculate the minus. Calculate the cube. And calculate sum and put n. Okay, that will be different step. Of course, you can do it all by once. Okay. But let me do it by step. Okay. Of course, it's very stupid, but we are just doing it slowly. But later, I can show you the other function that can be done. But you know how to substitute. Okay. But let's do this. The most easy, not easy, but most tedious way. Okay. So we start with n is equal to length of x. Okay. So this is first calculated the n. Okay. And the second one is I need to call x bar, which is mean of x. Okay. Then the next, this is next step. I would calculate. Next step is I would subtract the x from the mean, right? So I have the, maybe I call deviation, right? Deviation. This name I just make it up. You don't have to follow my name. You can just make your own judgment. Okay, will be x minus x bar. Okay, and then the next part is we have to raise to the power 3. Okay, just remember the equation here is I have to raise to the power 3. So I have to be cubic deviation. I have a cubic dot deviation will be deviation raised to the power 3, because raised to the power 3 means each own element raised to the power 3. Okay. Now, at the end, I have the numerator. Maybe I do the sum first, although this is rather stupid, but I shouldn't do in this way, but just sum of cubic distance deviation, okay, which will be calculated as sum, okay. And at the end, the numerator, numerator will be sum dot cubic distance divided by n, okay. So this is how I calculate numerator. Of course, you can do substitution and simplify the 1 line. both of you are okay. So I just solve the denominator of being done. Okay. Denominator is this thing squared divided by n and to the 3/2. Okay. So actually this we have this guy here already. So we can have square deviation. Would be deviation this one. Okay. And you can have sum of square deviation, which is sum of square deviation. Okay. And then we are done by the denominator, which is the sum of square deviation divided by n and raised to the power 3/2. Okay. The code is a little bit long, so usually you want to put some space there, then make sure that things are not so crazy. Okay. So you can see I put a space here, then probably you better know this part of the numerator, this part of the denominator. And check this again. The formula is correct. Okay. And y will be the, of course, will be the numerator over denominator. Okay. And we highlight this function. It's my skewness. Okay. And you can check the data if it's correct. My skew x, my skew y. Okay. This is exactly the same as what is given from the system. So this is the right function. So of course, here I have many non-necessary steps. You can just combine them all into one single step. That's how. Formula with very similar skewness, right? So Kurtosa's formula is like this one. Okay. So basically just change some number, then you should be able to calculate this Kurtosa's. So this is raised to the power 4, and then everything change a little bit. So if you take a look on this equation, let me show you the formula and the here, so you can follow this formula. Check out my code. sample proposals and sample units. And compare your result with Excel or visual sample units. Sample proposals. Know that you probably know how to solve. The left you hang on to after day and write your now let me do the kurtosis, okay? So what I do is I basically copy everything there. I say my curve, okay? And check again, because the formula is very similar, you can see what thing I can copy, okay? The numerator is similar, but except to the power 4. So instead of cubic distance, we say maybe quad, I don't know, quad deviation with power 4, okay? And I change to quad. Okay, then everything is done. Okay, so is it okay for the numerator? Nothing but this change from power 3 to power 4. But this is a rather TDS one. And the numerator will be the same, except we raise to the power 2. So basically, just instead of 3/2, we have 2 here. Okay. So basically, just what it changed is just this 4 here and this 2 here. Okay. And in order to test it, you can do my curve X and Y and check if that actually same as what the system give you, and you can confirm if this is right. 1.7, 3.2. It's the same as what we figure out. Yeah, 1.7, 3.236. So we're happily our function done correctly. Okay, so we also confirm that the moments package actually give you is the population version. I hope by yourself you can able to handle the sample work. I think now it's too difficult. It's almost time for the break. That's a break. Sometimes you can try on yourself or the sample during the break time if you want to. If any question, ask me. We don't have time to discuss, but I think we covered the important part of R. And after the break, our actually students is already there. So after the break, we talk about little bit 2 input. There's one variance and talk about some plotting. Okay. So then we'll go to the we'll go back to the some lectures, but we try to finish these R slides. Okay. I think it's important. Okay. So have a break. If you have time, take a break. You can write your own stuff. Okay. So let's resume. Let's do it quickly because I think some of you have tried. Just to make sure that the common mistake here is a bracket here. Okay. Make sure that you don't forget this bracket because you calculate this first. Right? R is only how to calculate like your primary school kid, right? When you have division and multiplication, they will start from left to right. Okay, so make sure that you have the bracket correctly. So that's why it's not always good to simplify things, right? So maybe you want to divide your calculation multiple steps, okay, in order to make sure that you are getting correct. Okay, so if I'm lazy, since I'm very lazy, so I just copy here and just do it. Need to get the answer. Explain what's going on. Some of this current n and deviation, I just copy the number. And I use the SD to get the file. Okay, because remember why I use SD here? Because SD, by definition, is n minus 1. Okay, all right. So, x minus power sample version. Okay. So I guess everyone can copy and paste, so I'm not going to go to the detail here. So next thing is covariance and correlation. I hope that's not too difficult, but here I have two input vectors. So B and R. Okay. So turn out to be this one is sample version. Okay. So if you want a population version, you need to do it by yourself. Okay. So the population version, but I think it's straightforward. Here is you have now function, as I said, if you have two input, okay, you need to have two input here is x and y, allowing the system know the two things is to be input there. And first thing you need to do the x deviation and y deviation, and you multiply them together, and you calculate mean of that, or sum of them divided by n. Okay, the same thing. Okay, the mean of product of the deviation, right? So I'm not going to do copy and paste. You can do it by yourself. Okay, but before we go in, do you have any questions? Okay, okay. So as the final thing, okay, let's write your own function for sample covariance and sample correlation coefficient. Okay, so let's do this exercise and then we'll go to some plotting. Okay, we'll do my covariance, my cover, and we will write a my correlate, my core. Okay, maybe COR, maybe my COV. Okay, so this is something we want to write. Okay, I just give you 5 minutes to do it. Okay, and we have two input, so we have x, y. Okay, and you calculate something. At the end, we have z is equal to something, and then we want to return z. Okay, and similarly, we do the same. Okay, so I give you 5 minutes to do it because it's so similar. But I calculate sample covariance. can work it out. Now it's so maybe I show you the covariance. Okay. So what actually just very similar to this one, right? So basically I just copy this guy here. Okay. And what is that is just sum of n6y divided by maybe I divide n first, right? And it's just length of x. Actually, we assume that x and y are the same length for x. So that's fine. X is fine. Okay. But if you really do a program, you can check whether X and Y are the same. Okay. It's a serious program. But we are not serious programmer at the moment, so the user actually do the right thing. And -1. Okay. Then in that case, then I'm done. Okay, covariance X. What is my input there? Let's do the same thing here. This is my X, and this is my Y. My covariance XY should be same as covariance XY there. Okay. So take this number. So that means I hope for it. So you the correlation coefficient. Okay. So let's go back to the slide. See here, correlation coefficient. Look at the formula. Okay. Depends on which formula we're going to use. The will be different, but let's use this one. So we have basically just copy this guy. Okay. So the numerator has no problem. It's exactly the same as sum of the, and then we don't need this guy. Okay. We can define, this is the way I do, doesn't really have to follow. SXX will be X deviation square, right? SYY will be Y dot deviations square, right? And the denominator will be square root of two things multiplied together is SXX times SYY. Oh, sorry, SYY. Okay. So let me check the formula is correct or not. Yes. Okay. So let's check this is correct or not. If not, then we go back and see what is the problem. I hope it's correct. Looks like it's complaining. Oh, I forgot the sum. Yes, multiply and sum it. Let's see. Oh, okay. It should be now, it's correct. Let's do it, check. This is correct first. So this is correct. And not the same as there. So let's see what happened. Okay, let me check. Sum of square divided square. Oh, okay, okay. Sorry. My mistake. So you can see if I even I do it in one step, that's what you can see. This process shows you how if there's no question, then we go to the very last part of the R thing. Is draw some diagram. Okay. So to do this, we need to rely on a package called ggplot. Okay. So we need to install the package called ggplot2. Okay. You may ask what is ggplot. Okay. GG is stand for grammar of graphic. So it's invented by a computer science Ph.D. in 10 years ago. So why is the grammar graph is that he proposed the way to draw graph in a very nice graph grammar. So it's a very well laid out structure. Okay? So let me install it and I show you the very nice package first, but before I go it, let me install, but let's go to the web Google and then show you what is ggplot2 first. Okay. Go to Google and type ggplot2, and then probably you want to type cheat sheet. Okay. And I think they have that. So you can go to the ggplot2 cheat sheet. Okay. So this one, I only cover very small part of it. So you can can see this one is very nice structure the grammars and then tell you how you combine data, different type of graphics, different type of data. It's a lot of syntax to be done, or you can check out the gallery, maybe ggplot2 gallery. So you can see there are many different kind of graphics. Okay. Maybe just pick up some, like see if I want to do a histogram. There are many. The most basic version. And here the code. They are how to draw this nice diagram. So this gallery contains like this. You can draw this kind of nice graph. There are many. Okay. There are a lot of minor detail you can control, but I just want to show the basic one. Okay, if you want to go further, you can see the many nice diagram, and it's professional style. So even though if you go to work, I mean, this is a widely accepted as a very professional drawing. Okay, even look at the business application, you draw this full out is very nice. You can see it's you can control every single element there. Okay, but of course, our goal is not to tell you how to really do it, but we just go to the basics. Okay, so one thing that I mean is different from what we have in the past is ggplot would use the data structure, not the vector by itself. We have to use the spreadsheet style because usually 2-dimension, right? You don't plot one thing. So basically you would be doing is we will be using the data structure instead of C, we will call data.frame. Okay. So because we are plotting 1-dimensional data for our purpose, so that's why we can define the vector first. And then I define the data frame, which means I convert the vector into a data. Okay. So let's run this 2-line. Let's copy this 2-line and put it here. So let's see what happened when you run this 2-line. So you run this 2-line. Okay. You will see X change it. Okay. But at the beginning of data. Okay. So ggplot have to work with data. Okay. Okay. Again, remember the data here is you click the spreadsheet button, data comes out. Okay, so that would be the first thing I want to say. Okay, the second thing I want to say is now is that's okay. Just copy and paste and nothing. But data frame is to tell the R that you are defining a data structure that we'll be using for plotting. Okay, and do remember that now we have the ggplot, so we install, so we ggplot2. Okay. Or I go to the here I have ggplot2, I just click this guy. Either I run this line, okay, or I click this button. Okay. Now I hope that's okay. Now what we are, or just I do it here again in case you can't see the beginning, but usually you put the library at the very beginning of the file. Then people know what kind of thing to install. This is not a very good practice, but anyway. So now we have the input, I put it in the spreadsheet, okay, data form, okay, which is this guy. Now all you want to do is draw a diagram, okay, and to draw, okay, you will, because this is a gram of graphic, so everything is done separately. Okay, you first have to define here the digit plot, what data you use. Okay, and here we have AES and MPS, which is like a declaration, and we have X is the X core, X dimension. X is called X because I put X. If you change this to ABC, then you have to copy it. X here refers to X coordinate. And my horizontal is equal to X. This X equal to what? And here you notice there's a very funny, very weird way to write that. R is your plus 2. Because as I said, it's a little bit different from the set R is draw a graph by putting option one by one. Okay, you tell them what the data, how you data, what's x-axis, what's y-axis. Then you tell more options, what's the color, what's the structure, how to make the scale, how to make the label, and many things. And do the switch one by one. Okay, but for our purpose, just tell them you want to do a simple thing. I want to draw a bar chart. That's a June bar. Okay, and you may ask how I get all these names. Remember the cheat sheet I tell you to look at here. The cheat sheet is here. Okay, and what I do is I do the go back to up. I'm doing a one variable here discrete. Okay, so it's like because the discrete data there. I'm going to draw this one. Okay, so let's do it here. ggplot our data, and I have enthusiastic x equal to x. Okay, and I add something is called geom-bar. Okay. Geom-bar means geometric bar chart. And once you do it, let's run this line. Oh, I forgot the bracket. So once you do it, you will see that it's bar chart. So it's very professional, okay, much better than Excel. Okay, of course you can make it very professional. One or two lines. Moment we just teach ourselves something. Any tutorial online can tell you. At least it looks good. And those of you who usually I want this to be used in somewhere, right? Put it in your Word document. So here there's a button for export. Okay. So you can just click export and you can save as image or PDF, and you can just use it on your standard Word document. So this is the first one to draw this, okay? So this is how we draw the bar chart in R. Okay, I hope that looks good. Is that okay? Anyone can draw it. Just go around. This is a little bit tricky. First time for you, look at the syntax looks crazy. For sure, it's crazy, but sooner or later, if you familiarize yourself with that and figure out that it's so convenient, that any software convenient. So just touch the basics, scratch the basics, so that you know how to go on. Because if I really teach you how to graph, it probably take 1 or 2 classes. But we don't have such luxury to do it. So that's why we need to be fast. Okay. So this is a graphic. You should be able to draw this. The next thing so far is the data we have so far is this number. Okay. But some of the time data are not number. Okay. They come in like this. Black and white, black and white, black and white. So that's what we call the ordinal data or the categorical data. That's why we under this male, female, male, female. Okay, this data. And you have a vector, and I have to convert it to a nominal variable. And how you can call it, once you do it to a vector, vector will convert this to a variable. This is a syntax. Okay. So let's copy the syntax and run, and then you will see how we draw. Okay. So the good thing about R is everything is reusable, right? So you can just go to website and search how to plot certain graph, copy the code, and we take this line and that. Okay, so that's a good thing. You don't really, you see something nice graph, you can just copy the code and just replace it with the data. You don't really need to worry too much about that. So if I draw this, you will see it's very conveniently they count how many B and count how many W. Okay? So you can start with raw data. So basically, you give a raw data like this. And this quotation mark means character. But you try to write this, otherwise it considers value. So if you want to input the data, that is a character. Okay. I hope there's not something too difficult. Okay, there's a slide. Okay. So sometimes what the good thing about this thing is, if you want to plot the height, it's not how many number of them, rather you want to plot the relative frequency. It's percentage, right? Instead of the how many count of them, you want to have over 100, over how many of them, right? So let's run this, then you will see the difference. Okay. So you have, let's copy here. Okay. This is same as this one, right? Same as the first one we do, except now I tell them, okay, when I plot this bar graph, okay, my y do not need to just take the x, but I want the y equal to the proportion. Okay. So let's run this again first and see what happened. Now this is 1, 2, 3, right? So if I run this another one, yeah. So instead of 1, 2, 3, that was 0.1, 0.2, 0.3. Okay. It looks very similar, but everything become very difficult. I hope you learn it in your high school. About count or whether. Is that okay here? So you can see it's rather simple. You can change your make your code very conveniently done. Okay. So where's the frequency? And this next one, okay, is trying to draw histogram. So instead of bar chart, we have histogram. So everything is the same except histogram. And one thing we're going to draw histogram is because the data is discrete, right? So the thing is, you have to how you combine what we call the beam width, which is that how is large is the bar. Okay. The answer you can see here is I have bar size of 1. Okay, I bar size 1, which means that each distance is bar at distance of 1. Okay. So what it means is in between 0.5 and 0.15 is considered this bar, right? 1.5 and 0.5. Okay, so the beam width is larger, the graph is more smooth. The beam width is very small, it would be much more irregular. Okay, so that is how we draw histogram. Okay, of course, for this one is looks the same. If you put 1, looks the same, right? Because should be same as your bar plot. Okay, so to make it interesting, you try to change it to 2. Okay, then you will see it's much more smooth, right? Because here it goes through all the way. Of course, the data now is like simple, but it's how you draw histogram. And you know that you draw histogram in Excel is a nightmare. Because you define the beam first and then have to do things very complicated. But how you do it once and for all. Okay, you can change the beam width as much as you like. It's helpful when you do any plotting. And here is the histogram. Instead of the frequency, you do relative frequency. So that's why y got density. This is something that y got density, and you do it on next week about one use random variable for about density function. You will see why it's called that. But just same as what we call the relative frequency. I'm not going to copy and paste, but when you copy and paste this graph, you see this kind of line will be same as where like the bar chart. Okay, but it's instead of 0, 1, 2, you have the frequency here. Okay. The next one is something we didn't cover in class, but actually it's very important. The box plot. Okay, the box plot is important because it shows the max, the mean, median, the first quartile, and the fourth quartile. People call this 5-point summary: the max, the mean, median, and also first quartile and first quartile. Okay. So look at the syntax here. This is almost the same, right? Except here are the box plot instead of bar. And because I want it to be X is a discrete, so I just call discrete. So so you can see here, this is the minimum, the median, lower quartile, upper quartile. So this graph is actually sometimes it's important on the cases. Why? Because you can try to see where the median is, whether it's closer to the mean or closer to the max. Now close this with the lower first quartile. You can see this graph showing you that this is very likely to be close like closer you can't see, but you can actually As you can see, part number summary, I'll give it. Folders is kind of looks like can tell, but can't really see too much. And here is the next one is called the column plot. Column plot will just say I have X and Y. Okay, I have 1, I will plot the height is 4, 2, the height is 7. So basically it's like X is the input number, Y is the frequency. So here is different from before. We have data frame, we have X and Y because I have 2 variables. Okay. So I have X is X, Y is Y, I use column. Okay. So that is how get this, right? X is here, Y is here. So this is the first point, second, third, fourth, fifth, sixth. Okay. So this is how you draw the bar chart. Okay. So the column plot. And if your thing concept factor, you also draw the same. Okay. But the thing is, when you're a factor, you have 6. This is not a number. That's the missing is not. Okay? Because 1, 2, 3, 4, 5, 6, 7 is considered as a name, so it's not a number. So they don't go to carry a factor. So the last thing on the cover is called the scatter plot. Okay, so this is the thing that you most use often because data will do regression. And our last topic, we have to look at how data. The thing you do is do the scatter plot and set up the syntax is 0 form. Okay, let's run this because I think it's the last thing we're going to cover today. Okay, let's go slowly for this one because I think the most useful plot for us is scatter plot. Okay, so here I have data X and Y. Okay, and do remember when you do plotting, you have to declare the data frame, which tells you what the data is. So let's run this data frame line. And once you do it, let's check whether your data is correct. So there's here. X is 1, Y is 4, and so on. So make sure that you correct. So this often is that you may miss it. Whenever you try to keep the data in the system, please check that is correct. Okay? Please check, at least check one more. First line and last line is correct. Because if you cannot be so sure that it's always right. And it can be garbage in, garbage out. So always check the data with the input. Otherwise, my lesson learned the hard. Sometimes we figure out that maybe X and Y swap or some reason that is not. But you must check, okay? And now I want to plot, okay? Just because X is X, X is Y, then you would plot this. Okay? So you may ask, okay, why X and Y, but if you change this to income, say, this is GDP, okay? And then maybe you have income and GDP, okay? Then you can, in this way, you put X equal to income and GDP. Okay? Then actually, when you do this, actually have a very nice structure. Okay? Of course, if you swap, the graph will swap, right? If you change income is here, GDP is here, right? Swap. Yes, that's pretty much of today. And the very last thing, just sorry to take 1 more minute. this is GG title, is equal title, and X label and the Y label. So that is, if you add this here, will give you what the X label, title, X label, and Y label. Holiday, Thank you. Oh, enthusiastic is 佢個打扮，即係佢個 decoration。佢意思就係話將嗰啲 data 放喺 enthusiastic data 就 mapping 呢個 enthusiastic。嗰個如果係 look at the menu. You make that or what? Look at the menu always. Yeah, copy and paste most of the time. I mean, if I do it, I'm not going to write from scratch. There's someone who already put the code online to just copy and paste. That is how you do. I mean, that's why I told you to go to the gallery and check out if you like this graph. Just copy the code here, right? There's only data here. Just change the data and you're done. Okay. So, Anju, is there any question? If no, I'm going to end the Zoom section. Yeah, nice we can.